Thank you for inviting me to speak to this event. Really excited, as well as excited to see both of you, as well as rest of your team. I know most of them. But yeah, let's get started. So my name is Satyavrat Arun Prabhune, and I am in San Jose, California. And today we are going to have some maybe introduction or going a bit more into detail on STEM so that you all understand what STEM is and what the future holds from your perspective and what you can get excited about. So you want to get started now? So here is what we are going to cover today. We will start off with some introduction. Then we will go over some background, my experience, and then some insights. And finally, we will wrap it up with any questions that both of you have here. Okay? So, STEM. I think most of you may have heard about what is STEM. It stands for branch or it's a science, technology, engineering, and mathematics primarily, and it's a nice acronym. So it stands pretty neatly, covering most of the aspects related to science and related areas. Now, in nowadays, there are also other areas which kind of it's spanning across, which covers sustainability, climate change, and a few other important areas which are very relevant to uh, us, our Earth, as well as especially for the next generation. You all kids who need to be really aware of what STEM is and what are the related areas. So be excited about this. It's a very interesting field, and this also goes beyond STEM into different areas. For example, the arts and other economics and things like that. But how does science impact those? So those fields are also kind of wrapped into this, and this is where it has global reach across all different studies, and so it's really important to understand what this stands for. So let's get into the next area from my introduction perspective. Who am I, right? And what am I doing here? So I'm here to explain you from STEM's educational perspective on what can we do for you all kids to get expert into STEM areas. Some It typically starts by understanding all the basics in the scientific fields, and that starts with basic science, which involves mathematics as one of the core fundamentals, then the science, and then it starts stemming into different fields, right? Which is biology, chemistry, physics, and the related areas. That's how it all starts off. And as you may have seen from mathematics perspective, the problem solving is extremely critical, and that the better you get at maths, the more you are going to get familiar with how to solve different problems, how to create a problem statement in a concise manner, and take it from there. That also helps you get better into critical thinking, and these aspects not only help you from STEM perspective, but it also helps you grow into other areas. So if you are a multidisciplinary student, it helps you apply these skills that you are learning from STEM into other areas. For example, if you really like music, you like plays, or you like sports, all of these different fields are going to get boost when you are good at STEM. So definitely go for that. This also requires and helps you get better at innovation, right? It's always, if you think from human perspective, we are getting better and better because of innovation, and those innovations are primarily coming from STEM. So very important. And now let us understand how did I get here, so that you can see what are the different career paths that take you from STEM into further into your career, right? As I mentioned earlier, my name is Satyavrat Arun Prabhune, and from my educational background perspective. So I started off with my high school. I completed my high school with focus on electronics. That was my one of the electives, of course, with advanced mathematics and things like that. But after high school, I essentially joined my bachelor's program with specialty in instrumentation and control. So it's essentially instrumentation engineering, and that involves lots of control logic. So a few years back, right before we had all of this, there were lots of these different factories, and the question is, who builds these factories? How do you build them, and how do you run those factories? That's where one of the field of engineering is called instrumentation engineering, and it can have different meanings in different countries. This was back in India. So you may hear different names, and that is also related to a branch of engineering called mechanical engineering, right? Where you do some mechanical related aspects, the gears, the motors, and some of all these different advanced structures and things like that. So it has angle of that. Then it can also have something related to civil engineering. It can have something related to electrical engineering, and it can also have something related to pure electronics or biomedical. So it is a very good way to look at it from, if you are interested in multidisciplinary approach, right? If you see yourself advancing in that, then definitely I would suggest consider something related to controls, instrumentation, building, and things like that. So that's how I started. It was really exciting field, and you get to know lots of good aspects on how to fully automate your, for example, your car factory. If it's fully automated, robot control, right? How do you do that? You need to know all these basics from engineering perspective. After that, I did my master's, and my master's was in electrical engineering. So I went into more specialized area where I learned a lot about how to build chips, right? And these are not the potato chips, but these are the semiconductor chips, right? And that involves actually understanding the basics of all these chips, understanding of how to design them and how to fabricate them. And there are different programming languages to build some of these chips, so you can understand that part. Then I also learned some of these aspects of digital signal processing, right? So these areas are where you understand building different images, how to analyze them, how to transmit them over the network. So all these different things come under DSP, and that's where I was doing my specialization in masters. I started to be more like my career job started, and I went industry essentially as an engineer. Okay, and I will cover some of the other aspects in few minutes. But later, I also did my MBA. So this is kind of the next step in career for some of the folks, and this is called Masters of Business Administration. Maybe some of you are already familiar with this track. This is a parallel track to business, to STEM, which covers some of these business aspects. But these are always combined. You can always combine these two tracks if you are interested to bring the STEM along with the business and some of the other aspects, management aspects to it, right? So these are different flavors. So this is one example of from me on how I progressed on that part. So from career perspective, right, we are going to get into, I will walk you through some of the examples that I have, and then we can see how STEM takes you to the next level. Who am I right now? So I am working at a startup called sima.ai, and I work there as a director of cloud software. Now, what do you mean by cloud software? You may be wondering. And software. So if we start from software, there are primarily two pieces. As you develop yourself into STEM, start getting into more specialized aspects. One is called primarily software and hardware. So primarily, as you become engineer, and especially in electrical and electronics aspects, right? Typically, you morph yourself into either software or hardware, and some people are able to do both in a much better way. So that's one aspect of it. And when you look at it from software, the the keyword is soft, right? And by that, what we mean is you are primarily working with uh, coding or related aspects, and hardware is primarily working with chips, designing electrical boards, and things like that. So I am primarily working from software perspective, and that means you are working through all kinds of different languages. Some of you may have heard while you are programming your robots, right? You are using Java programming, you are using C++ programming or C programming. So all of that kind of gets into a software world, and it has all more flavors to it, right? And there is, for example, the website that you are looking at. Those typical websites are all having at the highest level or the topmost level, which is the user experience level, and the website which is called the user interface, which is built using HTML and all the related technologies. So HTML, I'm using that acronym, but it essentially is called hypertext markup language. So it's another kind of language that is used to build all the different websites. And then this is middle layer where you are using Java and the programming and the things like that. And finally, there is a layer which is closest to hardware, the chip, at closest to the chip level, where you are using C, C++ kind of language to drive your robot, right? And that's how you bring all these pieces together. And then hardware is, as I mentioned, it's more tied up at the chip level. So what I am doing is working on software, and you may ask, what is cloud software? So from cloud, it means few years back, things started to there was a demand for very high scalability and how to do better in managing software, and that's where cloud infrastructure kicked in. And by cloud, it essentially means things are far away from you, they are somewhere out, you cannot directly touch it, and that's what cloud refers to. It's somewhere in a data center, right? In a remote place, if that makes sense, right? And so what I'm doing is I am managing multiple projects, and that includes, for example, at sima.ai, we are working on edge computing or machine learning at edge. So we will cover that in a bit, but essentially it primarily involves debugging the code. And by debugging, it means whatever you write, you need to ensure that it works correctly. If it doesn't, then you need to find out what the problems are, and then you solve them. It can be very exciting. At the same time, it can be very difficult at times if you are digressing from your original plan. So the STEM part is going to teach you how to be very logical, methodical when you do some of these things, and that is where it always goes back to your background on STEM, how well you are doing on that part, right? And all these skills start helping you grow in your career. So management aspect and all this debugging are very, very critical aspects as you move forward in STEM career. A few other things that I ensure as we get more and more customers, right? In this efficient and successful execution of complex projects is extremely critical, right? And that becomes more and more important as we, as customers demand our project, and there are certain deadlines. So, as part of the career, execution becomes very important. And during that process, right, you need to start planning on how you are going to use your assets and resources, and that can mean, for example, so risk management and the resource allocation, that becomes very important. And by resources, it means both human resources as well as material resources, right? How do you use, how many computers do you have? How many human participants, or how many team members do you have who can work on all these different aspects? And how do you ultimately optimize your process? And you are going to start off all of this in your school itself, right? You are working on different projects. How do you optimize your time so that all the homework gets done on schedule? You are able to work on your science project and things like that. So learn these in school itself, and you are able to apply these as you grow in your STEM career. Okay. So let's go to the next part, which is experience. So prior to SEMA, where was I working? I was primarily at Cisco, and I was a senior manager in a group called Collaboration. And we will touch upon that in a minute, so that I can cover it here. Okay. So this I have limited this to very top high level 5 bullets, so that you get an idea on how you can develop yourself in STEM. In my case, for example, when I completed my master's, I started as a software engineer. And in software engineering, one concrete example here is network devices. And what do you mean by network devices? So, for example, the call I'm having right now is I am at my home, kids are at their home, and we are all able to talk with each other. We are able to see each other. How does that all work? How does all that come together, right? So this is all connected to through internet, essentially, right? There are different types of networks, and internet is one of them. And through these networks, you get to communicate with each other. But the question is, how do you control these network devices? There got to be somebody who is managing them, right? Otherwise, things won't come together. So I was working on this software piece where we used to program these network devices. And by network devices, it means they are called routers or switches. At your home, you may have used or you may have seen Wi-Fi routers, right? And the routers which are connected to the Wi-Fi or the cable systems. That maybe those are old devices, but those are the kind of network devices, and they can be pretty huge. If you go to big service providers like AT&T or Verizon, if you check their offices, they have huge systems, and those are millions of dollars worth of systems, and you really need to be very careful when you program them, right? Because you cannot afford losing internet at any point. How does all of this come together? That's where you start writing control software for them. So I used to work on that part. I helped I went to Europe, and I also kind of wrote software for some of the big telecom providers in Europe. So it's pretty exciting. You get to go to world cities and enjoy once you get into STEM. Okay, so pretty exciting then. Then I was also working on very early video system, and one of those early system was called telepresence systems. That was in Cisco, and it was world's first telepresence system. The way we had put together, it was also huge, 1080p. That was very new at that time, very high quality, and excellent audio, and very high class, and very interesting. All the acoustics. So if you are interested in sound technology, right, then you are playing with microphones, speakers, and very advanced techniques you can employ and ensure that you are able to work through it. Again, I was part of that entire team, and it was very exciting because we were building so many of these new. We were prototyping some things, and then we were taking it to the next level. So it was very. I still remember the happy moment when we had our first call going, and we were actually able to hear each other. Right? That's pretty exciting when you build something new and you see actually working. That's the power of STEM. The next one is maybe you may have Jordan. Have you seen a phone in your school? It's a touchpad and some blackish phone. Maybe most likely you may have that phone. Have you seen one? Next time you visit your school, make a point, see the phone, and see if it says Cisco Systems. Okay. Cisco is a provider of millions of these phones which are shipped all over the world, right? And that is a very important one. How do you manage millions of phones, right? And in a particular school, for example, you may have 1,000 maybe not your school, but pretty big universities, they have thousands of these, right? How do you manage them? How do you control? How do you write software for these entities? So that's what I was involved into. I used Java for that. Then we used C++, and it was pretty exciting, right? And it involved lots of networking. How do you go through network? If certain network is the cable or the wire is broken, how do you detect it, right? How do you notify it? How do you, get so lots of these different things are involved in that part. And then I moved on to managing collaboration. You remember COVID time? Maybe you were too young, all of you. But during COVID, it was extremely important to connect over video systems, right? Because we were all trying to avoid physical contacts and be away from the social circles, right? So collaboration was extremely critical. For example, how do you get best video, best audio in limited bandwidth? How do you do that? So I was working on a system called WebEx in Cisco, and we used to manage millions of calls. I will tell you an example. There was a big country in Europe that went online, and in 24 hours, we just got 24-hour notice on getting that entire country and their schools on WebEx. How do you do that? As an engineer, you get to work on such exciting things. You make impact on human lives. You make human lives better. Wouldn't you be excited to do that? So consider something joining the stems, right? It's really important. And now finally, what I am doing is I'm moving into the machine learning part, which is, I think I'm sure you are all very excited and learning some aspects of this, right? So what does machine learning at edge means? So you remember I said cloud. Okay, we have yeah. So I'm at cloud, right? And there is another aspect to it: cloud and edge. By edge, essentially, what it means is devices which are closer to human beings. For example, if you have a door camera, right, at your home as a security device, it's called an edge device because it is connected to your near the human being or near the edge of the system, and that data might be processed in cloud, right? Are you following that? Right? So that's very important part. So cloud is a whole massive big thing, and edge devices are very tiny sensors or systems, but these tiny sensors are in millions and billions. So you connect these millions and billions of sensors to the cloud, and that's how you make everything come together. And you have a chance to apply machine learning algorithms at scale on edge. How do you, for example, you have a camera at your door. You don't want to wake up if a dog is moving around or a cat is moving around, but you want to get woken up if there is an intruder that is observed to the camera. So you build a software so that you are able to ensure that using machine learning, you can quickly detect something which is abnormal, right? So that's another interesting area. So let's go to the next from insights perspective. What do we want to do to get into this career, right? Of course, there is bachelor's degree. So after your high school, in most of the cases, you would need to get a bachelor's degree, and that too in most likely in engineering, and then you can easily get into software industry. Now, the reason I was adding some of those adjectives is if you have a lot of interest and you happen to be in a STEM area without the bachelor's degree, there are other avenues to get into it. And that can be, for example, you can get some professional certificates, professional degrees, which may not be, which are going to be kind of equivalent to bachelor's degree, but they might be in different tracks. So especially some of the kids might be very much, they might like very hands-on, right? So there are two aspects to getting a degree. One is after your high school, some kids do not prefer working with theory, and some kids would prefer to work with theory. So the bachelor's degree is going to be more towards theory to begin with, and then it starts getting more hand through labs and other things. The other professional degrees that I'm referring to are more hands-on and less on theory. They prepare you so that you are able to directly jump into a job and get started quickly. So you can, as you progress through this, evaluate the different universities or colleges, right? Especially state or community colleges. Those are low on theory and they can quickly get into the hands-on if you prefer that part. But if you prefer more advanced understanding of the theory, then you can definitely pursue bachelor's degree in some state or university, and that will prepare you well for software industry. And do you need a master's degree? You may, if you really want to get into advanced, specialized understanding of the area of your interest, then definitely consider master's. It helps you prepare in depth on some of the specific areas, and you can do more solid contributions there. Do you want to do a PhD? Yes, that's an option. And there are a lot of people who do PhD, and by PhD it means you are getting more further advanced degree into it. It's, for example, if bachelor's degree is typically 3 to 4 years, right? The professional degree that I was mentioning was typically is about 2 years or so, 2 to 3 years. Master's degree is between 1 to 2 years, and PhD is typically about 4 to 5 years. So it's a lot of commitment, but that's good. You get grilled into some in your area. You become an expert into your area. So definitely you can take that advanced step, and you can make lots of valuable contributions to STEM field, right? So go for it. Now, final conclusion. I think we covered most of it. That's really good. Uh, to recap, right? From all the discussion and the talk we just did, you may have realized STEM is not just STEM, it's not just science or technology or engineering and mathematics. Of course, they are not at all in isolation. These four work together, and they are not just together themselves, but they go across all other tracks: arts, music, sports, you name it, you will find STEM in there, right? So combine your hobby, combine your interest with STEM, and you get best of both the worlds. This is going to get you the fundamentals of everything, and then you can start applying as you get into your career, right? And there are lots of careers, as I was mentioning, starting with civil engineering, mechanical engineering, electronics engineering, electrical engineering, you name it. And nowadays, lots of machine engineers, machine learning engineers. So lots of choices you have to pursue. Pick one, and even financials, right? Financial, it's all even called fintech. So you can get into that as well. And finally, to wrap, I work in cloud software in machine learning, and I help things keep running, and I build new products. So that's the exciting part. And I hope you also like all these exciting things. With that, I think that's about it. Let's wrap it here. Oh, that's the important slide now. Any questions for me?
Thank you. Yeah, we do.
So, for the first question, I have, what do you think is the most impactful part of STEM from your experience?
The most impactful part is how do you make human life better on a day-to-day basis? That is the critical part, right? Do you improve lives of disabled peoples? Do you improve lives of non-disabled people? Do you improve lives of poor people, rich people, or do you make your planet better every day? All the sensors, the sensors that are tracking carbon dioxide levels, where are these coming from? These are all contributions from STEM, and that's what is really impactful when I think about it.
I have a question. How do you deal with, like when you do work, how do you deal with people who don't work well or don't do their job properly, like in the corporate workspace?
So typically, what happens is when you are working with people who are already kind of expert, right? And they might be going through some transition phase in their life for their personal reasons, where they may not be contributing to a certain aspect. Then you talk with them, right? You understand what's happening. You understand what's happening in their personal lives. Maybe that is having an impact on their work life, and then you try to help them go through that transition or difficult phase in their life and get them back into the normal field. That is one aspect. The other aspect is, if somebody is not an expert but they happen to end up in that particular job, how do you help them? You ask them to go through certain certifications to get that expertise that the job requires, right? And there are different reasons why this might arise, but we train ourselves, we train that person so that it gets to the level that we expect, and then we work it out.
Thank you.
For my next question, I have, how did you discover your interest for electrical engineering?
So I started off from the different aspects in instrumentation engineering, but later on, as I was delving deeper into all these different aspects, right? Electronics and a related aspect caught my attention on certain things which were kind of invisible, but at the same time they were happening, the logics and the circuits. And it was very intriguing on what exactly is happening. I need to understand this. And that's how I started to delve deeper into electrical engineering, because that is the basic aspect of all the things related to that area.
Just an extension of that question. Is there anything in your like childhood that led you to pick that career? That inspired from your childhood?
Yeah, we were in a small town where we had lots of these different aspects and small farm instruments that were moving around, and those were kind of in very naive state. But at the same time, I was also observing some of these advanced machinery in big cities, and that caught my attention, and that may have influenced my interest as I moved into higher studies.
Perfect. Thank you. I think Jordan, you have another question, and then I'll go with my last question.
All right. So, what would be your favorite aspect of projects in sima AI?
Sorry, come again?
What would be your favorite aspects about projects in sima AI?
The favorite aspects of the projects, right?
Yes.
So it's building new ways of allowing end users to adopt machine learning, because it's a very advanced topic, right? And the question is, how do you simplify so that it gets adopted on a large mass basis? So that's the exciting part, where I'm trying to I'm building a new product where we are making it easier and easier to apply machine learning on a day-to-day basis. And that involves, for example, you are working with a chip, but you don't need to touch the chip. You can still work through the cloud. You can still be at your home, but at the same time, you are able to access advanced aspects of the chip. You are able to program that chip. You are able to debug that chip. All of that by sitting at your home. How do you do that, right? And that's what is really exciting about the work that I'm doing right now.
That's great. And then for my last question, I just wanted to ask, yeah, you work at sima AI, and then you're director of cloud software. But then is there anything like why did you decide to join sima AI? And then is there like any like of their interests or their mission that aligned with your interests? And then like how did you become like director of cloud software? Or like why was that your choice basically? Mostly why was sima your choice?
Yeah, so if you remember, I had mentioned earlier that I was working in the collaboration, managing all this lots and lots of calls, right? Millions of these calls. Then, I wanted to see how can I combine that expertise with the machine learning, which was a brand new area, kind of when I started there, and I really wanted to kind of combine these two aspects so that it can be applied to edge. So combining three different fields together, right? Bringing the cloud expertise, learning of the machine learning, and the edge part of it. All these three combined give a very powerful force to make an impact. To Jordan's earlier question on impact, right? So this has helped me do that impact part in a very neat way.
Great, that's perfect. Thank you. Jordan, do you have any more questions?
I think that's all. So thank you for joining us today, and I think your presentation has really impacted us, and I hope it'll impact the first community. And
Yeah,
I think that's pretty much all. So thank you so much for this speaker presentation.
thank you.
Thank you, and good luck
Thank you.
to both of you. It's good to see
Thank
both
you.
of you. Yeah. Bye bye.